Problem 5. Evaluate the following limits. Limit x approaching negative 3, x squared minus 9, x squared plus 9x plus 18. Limit x approaching negative infinity of the same expression. Limit x approaching negative 6 of another expression. Let's go through one at a time. X approaching negative 3. Okay. Factor the numerator. This is a difference of squares. X minus 3, x plus 3. Denominator, factors of 18 which add up to 9, 6 and 3. So notice plus 3, x plus 3 and x plus 3 can be cancelled away because x is approaching negative 3. X is not yet negative 3. Okay. So I can cancel these two. I have x minus 3 over x plus 6. Now you substitute negative 3. I get negative 6 upstairs and 3 downstairs. So that is negative 2. Okay. Next, the same expression, x approaches negative infinity. Well, this is a rational function, guys. A polynomial over polynomial. Always divide by the highest power of x of the denominator. Okay. I divide by x squared upstairs and I divide by x squared downstairs. Division distributes. I get 1 minus 9 over x squared. Downstairs. Division distributes 1 plus 1 of the x's go away, so 9 over x, and there is no x, so 18 over x squared. Now when x approaches negative infinity, well, this fraction becomes very small, becomes almost 0. Limit is 0. Likewise, this denominator 9 over x is limiting to 0. 8 over x squared limits over 0, so I have 1 over 1. Answer is 1. This expression. Okay. Radical. So let me plug in negative 6 first. When I plug in negative 6, I get a 0 in the denominator. You can check numerator also gets me a 0. That is, I get a 0 over 0 which is undefined. That is, I have to simplify this in some fashion. Because of radical, it's the best approach is to use conjugate. So that minus 6, I'm replacing it by plus 6. Okay. So take your expression, multiply numerator and denominator by a changed expression. Where I had minus 6, it's become plus 6. Why would I do that? Because that gives me difference of squares, a factor and another factor which is symmetric, conjugate. Okay. So that's why whenever you have radicals, you look for conjugates because difference of squares applies. Okay. Square of the first minus square of the second. Denominator no change. Okay. So notice how I have to write the denominator x plus 6 within parentheses. Otherwise, this would multiply only the 6, right? So make sure it's in parentheses. All right. What happens? Square of the square root, they go away. I get 5x squared minus 144 and minus 36. Negative 144, negative 36 gives me negative 180. No change otherwise. 5 is common factor here. So I got the 5 out. I get x squared minus 36. Now that is a difference of squares again. So x plus 6, x minus 6. Downstairs is x plus 6. These two cancel, which gives me 5x minus 6, and that guy is gone, the rest of the radical expression. Now if I let x go to negative 6, with the plus 6, you simplify negative 6 minus 6, that's a negative 12. Okay, 5 times negative 12. Denominator 5 times 36, don't forget negative is going to be squared, minus 144. 180 minus 144 is again 36. Square root 36 is a 6. 6 plus 6 is a 12. 12 cancels the 12 and a negative survives, negative 5. Okay. Next problem. More limits. Limit x approaching infinity. Negative 6x over 10 plus 2x. Now this is a rational function. Divide by the highest power of the denominator. That is going to be x. So I divide the numerator by x. I divide the denominator by x. Well, numerator, those two x's cancel. I have a negative 6 over 1. Downstairs, denominator division distributes. I have 10 over x plus 2. Okay, now when you let x approach infinity, this guy goes to 0. Numerator is a negative 6. Yeah, negative 6 over 1 is simply negative 6. Denominator, this goes to 0 and I'm left with 2. Overall answer is negative 3. Alright. Next expression. Limit x goes to negative infinity. 5x minus 5 over x cubed plus 14x minus 11. X approaching negative infinity. Rational expression. Divide by the highest power of x in the denominator, x cubed. So divide the numerator by x cubed, denominator by x cubed. Division distributes. So 5x over x cubed, one of the x's cancels, 5 over x squared minus 5 over x cubed. Yes. Denominator also, division distributes. X cubed over x cubed, 1 plus. Look at that. That x cancels one of the x's. 14 over x squared minus 11 over x cubed. Now, when I take limit x goes to negative infinity, because x becomes larger and larger, this fraction gets smaller and smaller. 0. That's a 0. That's also a 0 because x is in the denominator. X is getting very large. So what if it's negative? The magnitude is very large. So this gets very small. In other words, I'm left with 0 minus 0 over 1 plus 0 minus 0. 0 over 1, that's a 0. Next. Limit x approaching infinity, x squared minus 10x minus 6 over 9 minus 5x squared. Rational function. Divide by the highest power of x in the denominator. Remember, rational means polynomial over polynomial. Always divide by the highest power of x in the denominator. Here it's x squared. The numerator over x squared, denominator over x squared. Division distributes. X squared over x squared, 1 minus 10x over x squared. One of the x's cancels. You have 10 over x minus 6 over x squared. Denominator, 9 over x squared minus 5x squared over x squared. The x squareds cancel. 5. Now, as x approaches infinity, these fractions go to 0 because x is in the denominator. The fraction gets smaller and smaller, approaching 0. So 1 minus 0 minus 0 over 0 minus 5. So 1 upstairs. Let me close the numerator. Okay, 1 upstairs and negative 5 downstairs. Positive over negative is an overall negative. Negative 1/5. Okay. Next, radical. This is an important kind of question. Again, radical x squared plus 14x over 13 minus 8x. Divide by the highest power of the denominator of x in the denominator. So that is x. Divide the denominator by x, divide the numerator by x. Now here is an important point, guys. X is approaching infinity. That means x is a positive number. When x positive, square root of x squared is x. Mind you, if x were negative, then square root of x to the power 2 is negative x. Okay, that's for negative. Remember this. Why? Because square root of, pretend x were negative 3. Negative 3 squared will be positive 9. Square root of positive 9 is positive 3. So from negative 3, how do I get a positive number? By putting another negative. Okay, negative of negative 3 is what gives me positive 3. That's what I'm going to use. All right. But right now, so this is the case when x is negative. Right now I'm looking at positive because I'm going to positive infinity. When x is positive, square root of x squared is x. So I'll take that x, replace it by square root x squared. Why do I do that? Because I have a radical upstairs. So I can combine the two radicals into one large radical. X squared plus 14x over x squared. Now this division distributes. X squared over x squared is 1 plus 14x over x squared is, one of the x's goes away, you have 14 over x. Now when I take limit x approaching infinity, this fraction goes to 0. This fraction goes to 0. I have square root of 1, that is 1, over 0 minus 8, negative 8. Positive over negative, negative 1 over 8. All right. Next is the same expression. Okay, just we saw, but I'm going to negative infinity. Divide by highest power of x in the denominator, that is x. Okay, same story, except when x is negative, yes, when x is negative, square root of x squared is negative x. So think again, when x is negative, pretend x is negative 5. Then negative of negative 5 becomes positive 5. Because I'm getting a positive square root, I'm always going to require a positive answer. So if my x is negative, I have to add one more negative to make the expression positive. So this x, I replace it with negative x root x squared. That x. Okay. See, look, I don't want negative x, I want all of x. So get the negative to the other side. That's what makes it negative radical x squared. Why would I do that? I have a radical and a radical, one big radical with a negative, you see, on the outside. Everything else is the same. Division distributes, that's a 1 plus, that's a 14 over x. This is 13 over x, that's all well and fine. When x approaches negative infinity, my fractions go to 0. Okay, so negative radical 1, that is negative 1, and here is a negative. So negative over negative is a positive. So it's a positive 180.